Our next speaker is Rebecca McDaniels. I call her Becky. She's Technical Director of the North Central Superpave Center at Purdue University. In that position, she works with states and provinces in the region and is responsible for research into various aspects of asphalt materials, mixtures, pavements. Becky holds a bachelor's, master's, and PhD in civil engineering from Purdue University and a bachelor's degree in English from Indiana University, who I think is a good writer. She's a registered professional engineer, has held various leaderships. Okay, blah, blah, blah.
That's enough.
Okay, well, take it away.
All right, thank you. Good morning. I see a lot of familiar faces, but I see a few that I don't recognize either. So as you may have gathered from that introduction, since I work for Superpave Center for the past couple decades now, I've mainly focused on hot mix asphalt issues. But just to lend myself maybe a little credibility with this audience, I worked for the Indiana Department of Transportation for many years, and in that capacity I was involved in some, we didn't call it pavement preservation back then, but some related projects like that. I also spent some time as a student in summers working for a local county highway agency. So, and now as Superpave has become adopted, it's routine in the Midwest where I work mostly. We're branching out and we're getting more involved in pavement preservation type work. So, plus over the past decade or two, we've done a lot of work with recycled and reclaimed materials. And I think all those things are kind of coming together now with a lot of synergy. So pavement preservation and sustainability is what I was asked to talk about. And they really do go hand in hand. As you gathered from Kevin's discussion earlier, and in fact the last couple of days, you can see how we can take advantage of what's already there, reduce our impacts on the environment, and extend the service life of the pavement, improve the smoothness, fuel efficiency, and safety, particularly friction. We can also have an impact on noise with some of these pavement preservation activities, which is another area that we've worked in at the Superpave Center for several years. So in this talk, when I talk about sustainable materials or recycled materials, I'm specifically referring to things like reclaimed asphalt pavement. You've heard from Kevin. That's a huge resource, a huge investment that we can take advantage of. Also, recycled asphalt shingles, slag aggregates. In the Midwest, where I come from, we've got a lot of carbonates. I'll get into this a little bit later. Friction is a big issue for us with those materials that are prone to polishing under traffic. So slag aggregates are our best aggregates from a frictional point of view. And we've been using them for quite a long time. But they can also help us out with pavement preservation treatments as well. Reclaimed rubber, again, Kevin mentioned that. Asphalt rubber is widely used in some areas, and it's an area that we could take more advantage of. Something that's really increasing, it seems like every month or so we're hearing about more and more bio-based binders, reducing our use of petroleum-based asphalt materials, extending our asphalt with other materials. So that's, I think, something that we're going to continue to see growing and can actually give us some benefits over just straight asphalt products in terms of rejuvenating and bringing back some of the oxidized recycled materials that we're trying to use either in place or in some kind of central plant recycling. There are also ash materials that can be used in some of these pavement preservation treatments, as we'll discuss here in a few minutes. So I'm sure you're familiar with RAP and RAS, reclaimed asphalt pavement, recycled asphalt shingles, widely used in many places. but there are also places where there's excess material. You do a mill and fill and put back 20% of the wrap into a new mix, for example. What are you going to do with the rest of it? So there are places where we have mountains of wrap, which is a shame because it is such a valuable resource. Both of these materials include an asphalt binder as well as aggregates, so it can reduce the need for both of those materials. Wrap typically will be around 5%. Binder varies, especially if you fractionate it or separate it into different sizes. And depending on the type of shingle, it can be up to 30% or so binder. And one advantage of shingles in some places is the aggregates that are used are very angular and hard. So again, coming from a place where even our gravels and our sands are mostly carbonates, those are good sand-sized aggregate particles that we can use. Of course, what kind of wrap you have, what kind of aggregate you have in your wrap depends on the source. And I'll give you an example here in a few minutes of where a county was able to take advantage of a much better aggregate than they normally would get by using wrap. So I'll probably use the term recycled aggregates here in this presentation, or fillers, recycled fillers. And what I mean here are things like slag, rubber, even glass, although I'm not going to really talk about that much, but that could be used. It has been used in some applications. And then ash materials like fly ash or bottom ash. So I mentioned the kind of crummy aggregates that we have from a frictional point of view in the Midwest. Our gravels may be 60% carbonates. So even if we try to use a gravel, it may be prone to polishing. So the standard in Indiana and several other states in the area is to blend these materials with a harder, higher quality, higher friction quality aggregate. In Indiana, I looked at the specifications for the Indiana State Highway Commission back in 1946, and they were already using air-cooled blast furnace slag back then. We've used steel furnace slag since the 1980s, or maybe even earlier. So we have a lot of experience with that. And in fact, interstates, you're required to use at least a blend of slag and carbonate aggregates, dolomite aggregates, to provide adequate friction. So we have a lot of experience with using that material, or those materials, and they work very, very well. I'll get back to that a little bit later. In terms of alternate binders, and as I said, we're finding more and more of these on a routine basis. We've got bio-based binders now. More and more are coming out. They may be based on plant materials, animal materials. Swine manure was a big topic of discussion. I was visiting with one of my states, and they offered me a sample to take back to my lab to use. I passed. I let them handle that part of the research. Even algae-based materials can be used to extend or replace some of the asphalt in our mixes. Waste cooking oils. Is it recycled or reclaimed? REOB. Recycled engine oil bottoms. I couldn't remember if it was recycled or reclaimed. REOB, or vacuum tower asphalt extender, is something that's been the subject of quite a bit of discussion recently. Some states are very concerned about it. Others are not seeing a problem with it. It's actually been used for quite a while. We just didn't know it. And there's research going on to how effective it is. But again, it's another alternative binder that could be used in some of these pavement preservation treatments. And people are coming up with new things every month. So now moving away from the sustainable materials, how can we use these in sustainable preservation treatments? And again, a lot of this has already been discussed over the last couple of days. Certainly with the field demonstrations yesterday, you saw how, or heard how some of these treatments can address different types of distresses, like cracking, raveling, bleeding or flushing, and so on. You see all that. And even on concrete surfaces, we can deal with some cracking, minor roughness, friction issues, and so on. So chip seals have been around for a long, long time. They can be used to seal the surfaces, restore the friction, and address some minor surface distresses. A study by the Minnesota DOT showed that regular chip sealing can extend the life of a pavement by 6 years. Since this treatment involves both an asphalt binder of some sort, an emulsion or a hot applied binder, and aggregates, it opens the door to a number of different sustainable materials that could be used. Reclaimed aggregates, wrap, alternative binders, and ground tire rubber are some of the first things that come to mind. Rubberized asphalt is used in a lot of places for chip seals. It reportedly can give you better chip retention. And as you heard, LA County uses wrap in all of their chip seals and has for several years. They also use it in slurry seals and microsurfacing. And the Indiana DOT, for example, has studied using slag in chip seals. Again, that's kind of our preferred aggregate from a frictional point of view. Tippecanoe County is where Purdue University is located. It's bisected by Interstate 65. It's, West Lafayette, where I live, is a small college town. We practically double our population when the university is in session, 35 or plus thousand students. But they're also very rural parts of the county. The Interstate I-65, they had a big mill and fill project that generated excess wrap. And the contractor in Indiana, the contractor owns the wrap. So they had this pile of wrap, and they couldn't reuse it all back in the mill and fill operation. So they provided it to the county, and the county did some chip seals with the product. So they got slag aggregate in their chip seal, nice dark colored steel slag. They found, since the wrap chips were pre-coated with binder, they used less emulsion in their chip seal. They got really good friction numbers. It was very economical for them because the contractor needed to get rid of this material. The county was really, really happy with it, and they are going to take advantage of using wrap whenever they can. Similar to chip seals, you can have scrub seals or sand seals. We saw scrub seals yesterday in the field demo. In fact, I was sitting in my office one day, about a week after I had submitted this presentation. I got a phone call from a contractor I know, who said, "Hey, would you like to see a scrub seal and then a cape seal?" And I said, "Sure, where is it?" He said, "Look out your window." They were doing this street outside of my lab. I said, "Where were you guys a week ago?" And I could have gotten some good pictures. But we did, the street in front of my office has businesses on one side and residences on the other side. Quite a bit of traffic, mostly cars, a few trucks, and they were doing a scrub seal. They put on a pretty heavy aggregate coating because for traffic reasons, they couldn't get out and do the microsurfacing immediately. Something about a football game and the traffic, although traffic was a much bigger concern when we had a good football team. But they were concerned about, giving people access to the stadium, those diehard fans who'll stick with us through anything. But they came back about a week or 10 days later and did the microsurfacing. The neighbors are very happy. It looks like a new road. It's much smoother, and we expect it to last for a good long time. And believe me, as I drive over it every day, I'll be keeping an eye on it. Now, in that particular application, they did not use wrap, but representatives from the county were out there observing it, and they were very excited. I'm sure we'll start seeing a lot more applications like that in our county. Fog seals, we're not putting new aggregates on the roadway with a fog seal. We're just locking the surface aggregates in place. But again, this is a place where you could use some of the alternative binders. And in fact, Pennsylvania DOT and Minnesota DOT, among others, have studied the use of bio-based sealants in these applications. Slurry seals, you use both aggregates and binders, again, to waterproof the surface and seal some low severity cracks. Depending on the aggregates you use, you can improve the friction as well. So again, this is another application where you can use both recycled, reclaimed aggregates and alternative binders, including rubber. Microsurfacing, again, aggregates and binders can be recycled, sustainable materials in these types of applications. LA County, again, has experience with using recycled aggregates in these applications. And as you heard yesterday at the field demos, in that particular example, they used cement as the filler, but this is an application where you could use some of those ash materials, fly ash or bottom ash, as your filler in that application. Moving on then to thin overlays and ultra-thin overlays. Again, you saw a thin overlay yesterday, a small aggregate size in an asphalt mix placed with a paver. This is a good application for recycled aggregates and alternative binders. You may have noticed, and it was explained that because of the uncertainties of when that demo was going to go off, they wanted to keep the mix hot. It was very hot, as you could see from all the steam and smoke. So thin overlays are a place where you could use warm mix technologies, reduce those temperatures, reduce the greenhouse gases, and energy consumption. Now this is just a photograph of a thin surface treatment. You can see a heavy tack coat there as well. I forget why I put that in there. But another thing that you could do with thin overlays is use very high percentages of recycled material. This is a plant in Indiana. It can do up to 100% recycled material in this plant. They've got 5 different wrap collars, and they feed different sizes of wrap in at different points in the drum to control the heating. They add a rejuvenator, fairly low percentage, and you essentially have 100% recycled mix, but it's central plant. It's very tightly controlled. Which leads us into in-place recycling. Almost by definition, it can be up to 100% recycled material. You can add additional aggregates if you need to, or as Kevin pointed out, if you need to extend or widen the pavement, which is a great application for in-place recycling, in my opinion. If you need additional material, you could put some wrap or virgin aggregate out in front of the recycling process and extend it that way. You get reduced hauling and all the good things that come with that, less fuel consumption. If you do hot in-place recycling, of course you do have the impacts of the heating and the fuel use and potentially fumes that come with that. Now, with a lot of these things, so we're talking in many cases, or most cases, about surface treatments. A lot of people would be concerned about the friction. I know In hot mix, that's a big issue. What's the quality of the aggregate in the wrap? What's that going to do to our frictional properties? Because providing a safe pavement is the primary concern, really. We've done a lot of work on that at the North Central Superpave Center, looking at the frictional properties of wrap. We had to find a really crummy aggregate and make our own wrap because we wanted something that would polish very easily. And so we did a lot of work on that in the lab, looking at the friction with the worst possible aggregate you could find. And we found that if you blend it with a high quality material like slag for us, you can use quite a bit of this material. And that is supported by a lot of previous research as well, looking at blends of materials that give you what's often called differential wear. So the softer particles wear away and the harder, higher quality friction aggregates remain to give you the friction that you need. So you can use wrap in these types of surface treatments. If you think you've got a poor quality aggregate from a frictional point of view, see if you can blend it with something better, right? But then you also have cases like Tippecanoe County where the wrap material has much better aggregate in it than they would have normally been able to attain. So don't be afraid of it, all right? It can work. You can also combine warm mix technologies with, especially with wrap or RAS. The concern with the binders in wrap and RAS are that they're oxidized, hard, brittle binders. The use of warm mix technologies can help to balance that out and alleviate some of the concerns about potential cracking with those materials. So again, pavement preservation and sustainability can go hand in hand. To extend the service life of the pavement, conserve our resources, and protect the environment. Very good opportunities to use sustainable materials while achieving all of these things. So thank you. If there are any questions, I think.
I was just wondering if there has been any analysis done to determine the net difference in producing a new ton of hot mix at a hot mix plant versus the hot in place operation.
I'm sure there has. I haven't done it. We've looked at cold in place recycling, but we have not done any research on hot in place. Anybody out there know? I'm sure it's been, yeah, I don't know off the top of my head, but I could look into it for you if you want to give me your card or something. Okay.
Any other
All right.
questions?
Well, thank you very much.